你等一下，等一下，我有没有那个写法？耶，是now，我 send 我的这个写法给你，你读一读。send 我这个写法给你。没有，你现在的重点是要把那个 Sn 跟 S2n 跟 S2n 加一的那个 conversion 拉到 Sn 那里。对，那个应该是需要 S1 比较大的东西。我发这个给你看，你看一下，你看得懂？我发给你啊。OK。Okay, let's start then. So let's revise the tangent plane of a surface. So basically, there are two ways to do this. Okay, so one way we speak of a surface as a level surface. So what kind of level surface is a general fx yz equals to 0. So what kind of a level surface appear in your mind? For example, x squared plus y squared plus z squared minus 1 equals 0. So what surface is this? This equation defines what kind of surface? Sphere. Okay, so this is a sphere. Okay, and then the other way to define a surface is using a graph of function of two variables. Okay, so graph of function of two variables, for example, z equals to sum fx y. For example, what? For example, just the upper hemisphere. The and upper hemisphere. Yep. So what's the difference between these two descriptions? How to draw a sphere? Okay, so it's like a vacuum ball. Okay, but hemisphere is just the top part here. So, well, I mean, you can see that graph is quite restricted because what? Because you can only write z in terms of xy. But as a sphere, you can describe upper hemisphere and lower hemisphere together. Right, notice that you cannot write z equals to some xy, right? In this case, where you split the z into two parts, which is plus minus square root of something. Okay. So level surface have um, more general than a graph. Yeah. Okay. Right. So last time I told you that we can implicitly differentiate f, right? So what do we get? We get del f del t equals to del x del t, right? dx dt plus, what's the formula? Did I do it wrong? What's the formula here? So del x del f del y dy dt plus del x dt equals to 0. Okay, where does this formula come from? Okay, come on. Oh, sorry. Last one is del z. Okay, so where does this formula come from? Xiao Yang. Where does this formula come from? The blue formula. Where does it come from? The tangent plane. Yeah, right. This gives you the tangent plane, but how do I obtain this formula at first? This is from the implicit function theorem. Okay, implicit function theorem. Now you can see that there's an extra t here, variable. Where does this t come from? Where does this t come from? So meaning, we need to have a extra variable that describe the position, okay, of point on the surface. Okay, extra position. You remember the tree or not? The tree, right? So if I let this equals to w, what's the tree you draw here? W written in terms of x, y, z, and then x, y, z will depend on t. Okay. So on the left hand side here is you differentiate this w or this capital F here with respect to, right? So there are three branches here. So there are three terms here. And there's a product of terms here because you have two branch. There are two edges in one branches. Okay. But what is this really doing? What is this really doing? One variable control the position. Okay, meaning there's a line on your surface here. So there's a line on your surface here. Okay, so there's a line. T is a time variable, right? So it's a one variable. One variable isn't the real line. So there's a line walking on the surface because you satisfy the level surface. Okay. After you differentiate, okay, what do you see here? This term here can be split into dot product. So, so uh, so we can split this into a dot product like this. Del f, del x, del f, del y, and del f, del z. Okay. Okay. So I can split into dot product like this. And what's this column representing? Okay, so this is what? So well, I mean, let's give this path a name. Let's call it RT. Okay, so where RT is equals to ST, YT, and ZT. Okay, so this will represent a curve or path on the level surface fxy z equals to 0. Okay, so in this case here, on the left hand side, the vector is just the tangent vector of your path. Okay, tangent vector of your path. No. Okay. Okay. If you are, yeah, I mean, there are a few ways to write it. I mean, I can also name it as R1T, R2T, and R3T. Three component here. I split RT into three components. Does it make sense? Split, I split the coordinate into three positions. Fair enough. Why three positions? Because this graph lives in R3. Okay, so you need to tell me in X direction how much, Y direction how much, and Z direction how much. Is it true? Like where is the projector from me? I need to move two steps to the right, and then move maybe three steps forward, and then move out five steps, for example. Okay, no. Because this point is in R3, so there's three coordinates to discover. Okay, but what's the other side here? What's this thing? Del F over del X, del F over del Y, del F over del Z. This is nebula F. Okay, which is the gradient vector of F. Okay, so this is the gradient vector of F. And then this is the tangent vector of your path. So meaning what? Meaning these two vectors are perpendicular to each other if they are dot product is 0. Okay, so meaning delta F is, oh sorry, nebula F is always normal to all the tangent vectors. So in this case here, tangent space is a collection of all the tangent vector. So the normal vector to this tangent plane will give you the formula of your tangent plane. Okay, so in this case here, this case, tangent plane at, let's say, x naught, y naught, z naught is what? What's the formula? What's the formula? What's the formula? 哎，不要等我哎，看一下你的 note。想哎，也是啊，检查一下你的 note。partial f over root x times what? Equals to 0. But there's other way to find, right? If I have z equals to fxy, what's the formula in this case? This case, what's the formula? This is the first way we describe the tangent plane here. So how about this case? So what's the formula here? Tangent plane at uh at where? Let's say also s naught, y naught, and z naught. What's the formula? Z minus z naught partial x. Plus. Okay. So let me bring these two formulas together. So what's the difference here? One is capital F, one is small f. Okay. And then one you need to evaluate at x naught minus z naught, but the other one you just evaluate at x naught. Are they the same or not? Okay, if you look at the real geometry here, and then you look at the point, let's say the north pole. Okay, the north pole here. They should define the same tangent line, tangent plane. Because they are really the same part of the field. They should be the same. But can you see they are the same from the formula or not? From this two formula here. Can you see that they are the same? How to see they are the same? I'll let you think for about 1 minute. Can discuss with your friend. How are they the same? How are they the same?你在讲什么东西？哦，我反了哈。I think okay, yeah, thank you. So inside here should be 1 minus x squared minus y squared. Like this? Okay. Yeah. Okay. Any idea? 箭筒. Eh, 箭筒 salah. 小朋. Huh? Divide? Divide what? You mean, okay, sure. Divide? Okay. So you mean, yeah, x. Like this? Like this? Huh? Sorry? 加了，加在另外一边。我加右边。哎，左边。Yeah. 这样子啊。Can you make sure that del f, del z is not 0? Anyone have other idea? Partial f partial z 不是 zero，有吗？level surface 好像我们不管吧，level surface 我们不理，只有在I mean not quite. I mean I claim that we can deduce the tangent plane for the graph of two variable. We can deduce from level surface. And level surface is more general. Okay, why is it more general? Because if you know that z equals to fxy, you can create an equation such that z equals to f comma y equals to 0. And then this is a particular example of level surface. So what's your capital fxyz now? Is z minus fxy, right? Because capital fxyz is just telling you there's a function relating x, y, and z. In particular, z minus fxy is a function that has z, x, and y. So can you try? 拿你的笔跟纸出来 try compute the gradient of z minus fxy. What's the gradient of this z minus fxy? I try and compute what is the gradient of f, sorry, not f, z minus fxy. Okay, so what's this? What's the gradient of this? Huh? So first term, what do you get? It's x over square root. What are you computing? You compute an exact example here. Just compute for the general f is enough. What's the computation for it? You minus one. Okay, so maybe I write more stuff down here. So 1 is partial over partial x of z minus fxy. Next, partial z minus fxy over partial y, and then partial z minus fxy over with respect to z. Okay, so this is the gradient of this function. What's the answer? Yeah. Mm-hmm. Mm-hmm. Dirangkat this? How do you differentiate this function with respect to x? You treat everything in other than x constant. So z goes to 0. And then you just partially differentiate your f with respect to s. And then similarly, the rest, you do it the same. So using formula, what do you get? 1 times z minus z naught plus, not plus, is minus del f over del y times at the point s naught, y naught, z naught. But in this case here, it's just y naught, x naught, y naught, right? Because my function only have xy at y minus y naught minus del f over del x at x naught, y naught, z naught times x minus x naught equals to 0. Okay, so if you rearrange it, you really get the same tangent plane formula you started with. Okay or not? Okay, can you see it? 原体吗？原体吗？ Okay, so we can use the tangent plane of level surface to deduce tangent plane of any graph of function of two variables. Okay, because level surface is more general. Okay, is it more general here? You see? Okay, it's more general. Okay, because function it has restriction, right? The vertical test, the vertical line test. Okay, so function is more restriction here. So you can see that if we study the level surface on a sphere, we can study the upper hemisphere and lower hemisphere together. Okay, but if you can only do surface, you can only do one part of the sphere. You cannot study that. Cannot. Okay, so if you want to memorize the formula, I think I suggest you to memorize this because this one can deduce the other one. And you don't need to memorize both. And one can deduce the other. Okay. Okay. Right. So this is about tangent plane. Okay, next we'll spend time discussing about extreme value theorem here. So we'll spend time discussing extreme value theorem. So what's extreme value theorem again? If f is continuous on a closed bounded set D, then f will attain both an absolute maximum and absolute minimum value on D. Attains mean achieve. Achieve. Okay, it will have both maximum and minimum. Absolute maximum and minimum. So meaning you can find the highest point and the lowest point. Okay, out of 4. So now we'll discuss a little bit on these two conditions here. Closed and bounded. Okay, so last time we briefly discussed that a closed set should contain all the boundary points. Okay, so we'll make these definition precise. And I'll tell you what is bounded mean. I mean bounded in one variable is easy, right? Okay, you cannot be greater than one number. Sorry, yeah, you cannot be greater than one number. You must be greater than some small number. Okay, so you have a bound region. But how about R2? How to bound an R2? Okay, maybe this classroom will bound this space here. Correct? Let's say there's no door, you cannot go out. So in general, how do we define a bounded set in R2? Okay, so let's start with closeness first. So we'll start with some collection of definition. So I'll introduce these piece of definition. I think you should understand them, but maybe not really using them much in this class, but I want you to understand them at least. And then when you do these questions, try and think about these ideas. Okay, so first, to define close, we need to start with open first. Okay, let's start with open. Actually, I speak of open before, right? There's one kind of open thing I talked to you. Open what? Yes, open this. So let's start with an open this. So I talked to you open this before. So let's make it precise again. So I denoted DAB delta. Okay, DAB delta here. So what's open this here? This open this has radius. Okay, radius delta greater than 0 and center at AB. Okay, so what's this? Okay, so basically this is the set. Okay, set of what? Set of all points. Okay, all points x, y in where? In R2. Okay, but is it all points in R2? No. Okay, such that the distance between these points with the center is strictly less than delta. Okay, so how should this picture looks like? You should start with a you should start with a center first. Okay, you should start with a center. Let's call it AB. Okay, and then you look for all the points, all the other points, such that what? These points are within delta distance. Okay, so let's put a delta distance here. Yeah, no. But not including all the points that is exactly on the delta distance. Okay. So this is called an open disk. And and remember that last lecture we also touched a word called a neighborhood. Okay, so for in this class, you can think of the neighborhood is just, let's say, a neighborhood n of p in R2 is really just an open disk. Okay, so you regard your neighborhood as open disk here. Maybe in future you regard a neighborhood as something that contains an open. It's more general. That's more general. Okay, but now we take neighborhood as an exact open disk. It's fine. Doesn't make too much difference here. So meaning neighborhood is just open disk. Okay, open hood is just neighbor. It's just open disk containing P. Not that I said open disk containing P. I didn't say open disk center at P. So open disk center at P is one of the neighborhood of P. Do you get what I say? So let me draw to you again. So if I have P, what's the neighborhood of P? You can take a open disk that's centered at P. Okay, you can take a neighborhood that's centered at P here. But you also can take other neighborhood, right? So you can take neighborhood that's centered at other place as long as it contains P. That's all. So all are these are all the neighborhood. 对吗？对，你可能有左边跟右边的邻居嘛，对不对？你跟左边的邻居跟右边邻居关系一样好吗？不一定，是不是？可能你跟左边的比较好，可能跟右边的，但是他们都是你的邻居。As long as this neighborhood contains P. Okay. As long as this open set contain open this contain P, we'll call it a neighborhood. Okay. 有问题吗？ Okay. Okay. So after this neighborhood open this here, we'll define what is called the open set. Okay, so what is it? An open set is a set X in R2 is called open. Okay, if for every element in X there exists an open disk. Does it open disk? So how do we denote the open disk? So you just need two ingredients. You need to tell me where's the center, like the circle, and the radius, such that what? Such that all points here live in the open disk, and then this open disk will live inside your set. How do you imagine this? So you start with an open set X, okay, and then you look at every point inside your S. Can you find an open disk that cover this point or not, such that the whole disk will live inside the set? Okay, so the first claim is, open disk is an open set. Okay, try and think about it. So if I draw the open disk, let's try. You try and draw an open disk. Okay, is it true that if you go to any point inside your open disk, you can find another open disk that contains this point inside open disk? Is it true or not? Think about it. Is it true? Maybe you think that yeah, close to the middle is easy to find, right? Okay, close to the middle is easy to find. How about some point very close to the boundary? Can you still find open disk or not? Can you still find open disk? So let's fix our center. Let's fix our center. Let's say A, B. Center.哎，边界重合什么意思？As long as you satisfy these subset inclusion here, as long as you pick the open set, all the point will live inside X is okay. You don't want to pick your open set something like this, contain some point outside. You cannot do this. As long as you make sure that everything inside your open disk is inside your set X. So let's call this set X. Okay, maybe I give you some real number to work with. Okay, real number. For example, let's fix this point, the origin. Okay, let's fix our radius. Let's say radius 2. Okay, and what sort of point we can pick here? For example, 0, 1. Let's say this point is 0, 1. And let's pick another point. Maybe the other point is, let's say, this side is what? Maybe 1.5 comma negative 1.8. So my question is, for these 2 points here, can you find an open disk that contain these 2 points and then live inside this ball here, this open disk? 真吗？来，一人找一个，什么？不懂，没有听到。Okay, so given these 2 points here, 0, 1, and minus 5, sorry, 1.5 minus 1.8, can you find an open ball, open disk that contains these 2 points such that the open ball lives inside this whole S here? So what's this S here? Can we write down this S? So in this case here, our S is just D of 2 center at 0, 0. 看到吗？来，一人找一个来谨慎，找这个。什么？这个点出去了，真的吗？你说一下。2.3，要不要把它弄出来一点？把它弄进来一点，不要太多。 我想一下，1.3跟减1.6，哎，有出去吗？OK，你们有一个 key point 要找到啊，还是出去啊？这样容易出去对不对？有想一下，这么这样容易出去啊？哦，我到边边了。OK，把这个挤过来一点。一还是不可以一啊？这边啊，出去啊，0.7。I think you found some key point here。走，又出去啊？没有出去，没有出去，但是是号码多少？蛮重要的，等一下要用到。1.38哈。Okay, so this here is a key key calculation here. So 1.38. So this angle is this distance is 1.38. Okay. So from 010 to 00 to 01, what's the distance here? Distance is 1. Okay. So can you find an open ball around 01 that's contained inside this D2001? 找到，懂什么意思吗？不懂可以再问。不懂。OK，open this 知道什么意思吗？什么意思？黄色那个，第二那个，我要找一个比较小的that contain 这个0.1这个点，找得到？用什么找？给我那个 open this，给我那个 open this，给我一个比较小的 open this that contain 0.1这个点。所以你要告诉我它的 center 和它的 radius，所以你应该取什么 center，应该取什么 radius that contain 0.1这个点，是吗？啊，00啊，D00，然后它的 radius 要多大呢？一啊。OK，我们试一下看一下这个 diff 有没有 contain 0.1这个点。没有，我们 test 一下看看有没有 D001是什么意思？center 在00，radius 是一，但是 radius 一的那些点我不拿，对吧？因为是 strictly 有吗？这边 because it is strictly less than delta，等于一的我不拿哦。OK，那我们看一下01这个点和00的这个点的距离是多少？距离是一。OK，说你的 open disk 啊，刚刚好把它排除在外面，所以你要把它收进来，你要怎么办？对，你要有一个 open disk that contain 01这个点，应该怎么办？放大咯，放多大？OK，你觉得够吗？为什么够？因为它的 distance 是小于1.5。So yeah, sure, you can pick like this. Okay, so let's call this D 1.500. Yeah, sure. So this will satisfy that this open disk contains 01 and then live inside X. Why live inside X? Because all the distance here is just less than 1.5, which is less than 2. Okay. Okay. How about for this one? 1.2 minus 0.7. Can you still find an open disk? Okay, that contains this point but entirely live inside the circle. I will check. 对吗？还有空间嘛？有空间吗？有没有空间？有没有空间？再画一条长的线给你看。等一下把这些移走先。对吧？对呀。Well, I mean, so there's another line here, right? 还有没有空间？对，大过1.38，小过2。现在我要 form 一个 open disk，form 得到吗？能不能 form 一个 open disk 在这边？能吗？OK，要取什么 open disk 在这边？嗯，sorry，0.1，这样讲算出来的0.1，这样算出来这0.1。radius 只要小于2减1.38除2，除二就更小更好，但是不用除也可以，对吗？因为因为这个距离已经是来距离是什么？radius of 你的 circle，除二就更小一点。如果你打2减1.38是什么东西？是这个点到它的边界的距离。只要你能够在这里面框框里面封一个 open disk 就好，最大的那一个肯定就是2减1.38，就是这段距离了。如果你用2减1.38这段距离啊，so let me move it more precise a bit。这样，so let me so let's say 这个是你的点，so what do you use? You use 这个2减1.38 and then form a 这个在这边，我是相切的。啊哈啊哈，OK， so let's write down the open this formula d of 什么东西啊？0.62 center at 1.2减0.7。OK， so now you need to prove that whether this live inside d2 of 00 or not. Right? Okay, so you need to prove this. Okay, so how to prove this? Huh? Everything inside the set of the left hand side, you need to show that. So want to show that if x live inside this here, then x will live inside d2 of 0, 0. Okay, so well, I mean, let's not use x only, use xy because we live in R2. Okay, how to verify this? So suppose the length between xy minus this center here is less than, strictly less than 0.62. Okay, what we want to show? We want to show that the length of xy minus 0, 0 is less than 2. Okay, is it true or not? 就算罢了。OK，就开出来算了。怎么开出来算？开出来算了。What's the formula? X minus 1.2 square y minus 0.7 square is less than. Huh? Oh, yeah, thank you. Thank you. So this is less than 0.62 square. So does this imply that x squared plus y squared is less than 4? 那算吗？怎样 triangle equality 呢？啊，OK，你没有学过吗？triangle equality 有学过？OK，说怎么用？你跟我讲。对，从哪里开始？现在从哪里开始？Suppose A 和 OK，然后这个擦掉，这个不要，不要啊，真的不要。OK，放这边先。OK，implies what? The length of xy minus 0, 0. 哦，喂啦，等一下说，这个 0, 0减这个是吗？All right. Okay, so I think we need to rewrite this because we should start a new. Okay, 我感觉这个真的是没有用的。下 So I think we need to put our goal later, and then we should start with one side first. Okay, and on the one side you have this. Okay, and then 你要算什么？呀，0.6放哪里？你塞了个中间东西。刚刚英国离它好像有另外一个方向，点的那个方向。点的那个方向有用吗？点的方向是什么？点的方向，会对吗？点的方向。So okay, let's recall triangle inequality. So you have this is less than plus y. Okay. Um, 点的方向讲 deduce 啊，sorry，要加绝对值哈，我也是觉得要加，这样子，OK，这东西有用吗？这东西好像有用啊，这东西好像有用，如果我们有这个东西的话，诶，哎，你们有证过吗？你们有证过吗？有看过啊？这样 OK 啊，我用啊，OK，我用，OK，我觉得这个好有用。Let's see 啊，so this will implies that 这中间的东西 I can compute already, right? What is this middle thing 啊？What's the length of 这个？刚才你们算嘛，用计算机算的嘛，1.38，是哦，1.38。OK， this absolute value is less than 0.62. But this means what? The difference here should be strictly less. Thank you. Strictly less than 0.62 greater than minus 0.62. But if you move 1.38 to both sides, what do you get? Your x, the length of xy should be less than 2 greater than 6, 7, 0.776. 对啊 Yeah. Okay, so all your xy is living in this radius here. Also, in particular, it is less than 2. Okay? So 你的边界不用担心的。OK 吗？有问题吗？有问题吗？因为刚才逸翔哦在问哦，这个边界哦有没有问题，会不会撞到，对不对？那我告诉你不会撞到，因为我的点全部是活在0.76到2里面的 radius，不会撞到，明白吗？这个就是把一个现实生活中的问题问去数学里面，数学的 inequality 告诉你它不会撞到。其实这个就是 analysis 要做的事情，把很多现实中的问题变成数学化。OK，呀，所以为什么最难的 pure maths 课是 analysis？因为我们把很多的那种，就是你平时会问的问题，我把它变成数字化，变成这种 inequality。但是刚才我问的时候，会不会重合那个点？边界应该，边界应该是重，就是那条那个去到的那个点，那个边界线啊，OK，应该合在一起。对，那个是会合在一起，但是我是说那个点会跑到那个 boundary 去，综合就一个点，对，但是需要证明，虽然看着蛮明显，但是需要证明，对吧？还有什么问题？然后提了不出，然后然后它不是，它不等于那个边界，但是它无限接近边界，那它也有一个直接的圈圈。呃，因为一个 point must be a finite point，就是它已经选定一个点，所以你们从这两个例子可以想到说，不管我在里面选哪一个点，我都可以 form 一个 ball 嘛，form 一个 open disk。因为什么？我只要选定一个点，我就可以知道 distance between this point and the center already，肯定会有距离的。然后那个距离你只要拿这个 difference 就好。OK，但是不会有 IZ 的问题存在。我们没有考虑一个什么无限会跑的点，没有，它是一个 finite 点。一选好一个点，它就是一个固定的距离啊。OK，我们没有什么那个点会跑的，没有这样的点呢、没有第二点，因为我们一选定那个点就是在这里了，它就在这里啊，那个点是不会动的。You get what I mean？ 没有 limit 这个东西在这边现在啊，就算它无限接近，它也是无限接近啊，它没有到那边，所以它还是有一个位置的。then 还有一个 finite 的 radius，you get what I mean？而且你不能够去选这个 boundary point，因为这个 boundary point is not in the set，全部都好 OK 吗？有问题吗？来，慧琪有问题吗？知道在这里面任意选一个点，我都可以 form 一个 ball 嘛？怎么 form？来，很快你回答一下，我们就 take a break。怎么 form 一个 open list？也是啊，好下去，好，0.76个东西，这个东西谁跟谁之间的距离很重要。黄色点跟红色点，哦，这个点，这个啊，OK，right，good，very good，把这个距离怎样找出来？这是重点来了，没关系，good，对，没有错，差不多要到了。怎样找那个点去那个黄色边界的距离？嗯哼，嗯哼，在这个情况呢，这个1.38是什么来的？OK，00代表什么？Center of the this。OK，从 center 到你的距离，然后，但是怎么去找你刚才讲的那个距离？二是什么东西？Good，谁的 radius 线？这个圆是哪一个圆？很多圆在里面。黄色的圆是我们一开始的那个圆。OK，呀、所以很重要啊，这些东西啊，你不讲清楚啊，你就是乱了，总分乱。要讲得很清楚。来，这个就是 analysis 还是 calculus 的重要的重点在这边了。OK，为什么我们做 differentiation？因为我们就是要挖进 locally 去看它那里的 tangent line 是什么，我们要把东西看清楚。OK，清楚是这个 calculus 的题来。OK，主题一定要学到这些，不是学 derivative，不是学 derivative。OK，这个 calculus 最重要的题目就是要把东西挖清楚、算清楚，因为很烦啊。其实 calculus，yeah，其实 calculus 这门课很烦，我比较喜欢 algebra。OK，let's take a break until 10:17.
说小，如果说小的话，就会有算这种。
而且你要做什么呢？你要找 horizontal 和一个 point，但 critical point 只是最高跟最低的，不是 complete maximum。然后就是谁是 very point，然后是 stationary。你找的这个 R prime T 啊，嗯，然后是这个然后是这个，你把这个换成图，这个换成图，因为你的这个都是这样的，然后你找的这个换成这些，然后做的是我们把它画在 x y 那个表才会变出你的，然后在刚才讨论是我们去画那个那个推东西，所以在算的这个时候，我们其实在算，嗯，用地铁的这个 y 这个就是 df dt。因为为什么我们这样子讲，我们说就 dy 的 dt 的原因，因为在放的时候，我不让它在 y 地方，因为它是回声，它一定要在 x 地方，这样的话我才可以画出那个。所以我们是，所以在 determine horizontal tangent 的时候，我们其实是 differentiate 这个 respect to t 去算什么点的等于，要乘起来，乘什么起来的？我先讲，你是说你单 differentiate 这个 differentiate 不到？应该是 differentiate 得到，只是你找不到那个 root。differentiate 就是 product root 啊，对不对？找不到那个 root。可是你看它的点就是这样多多多，所以是说你要找那个 numerical solution。你不是有学过那个什么 Newton method？那这个你们科学生不是学吗？不是说学过，Yeah，类似那种东西哦。
可是你根本
但是又在 form 那个什么？
好，你真的讲的，
对，就是用那种。
那是讲这是他的问题吗？
那我们这边人做
就了
啊，是吧？不是，这个新就是说号码，try 了一个号码，你拿到新的，但新的再拿这个新的放进这个 formula，再算一个新的出来，把新的算出来的东西变旧它，然后再算新的这样子。然后他的意思是说，这个 process 会大概停在某一个号码，也不会完全停啊，就是靠近那个规模。
因为你算出来的要给你取翻过来，那个号码可能你是从3串到2.1、2.111、2.1。
这样好。
有没有啊？所以你看你的答案是那个数点多，这个就是你所谓的算不到，因为我们不能够去。不过这个叫做 numerical solution 哦，我们不能算到很精确。对，要算到多准，麻怎么哎，那怎么搞？就是 I mean 什么时候知道？题目大概是这样的。3个星期几个人？哦，算几次罢了。
那你算太久吗？如果是题目的话，
不是，他应该是要说来差不多。
哦，就是停在第几个小数位，然后它就没有变的那一种。
啊，
也是有，也是有。
像表面先说算几次不可了啊。我知道，但是就很多时来着。
也是等下我们是那个3个的新闻会。
是你一直 interact 过后，差不多它前3个都是准。我们3个都是准的，大概一两三。在理想情况下是会这种，因为他的因为他可能是还有你的以为学生吧。
像我这边算。
然后你是在算这个 graph 的，我现在要算那个，
你知道，毕竟啊，我这个还是，
那你就是对着它做，我忘记对着它做，现在打戏啊，就是 TY 来按时间多少？
哪一个？
我这个，你要找你的从这个手里标才要找这个。
你说那个什么？
那应该就那个1000号
去做饭才对呢。
对。所以你应该要找大概是这个位置，你的路如果是对的话，应该要停在这2个位置。
为什么主是什么主？哪个？
条门停在这个位置，靠近你这个点上，然后还有一个点是在26个。点多了，
其实刚刚那个子类似的，
最近谁可以这去？
是这样，
反正像你就你要
那就电容那样会靠近这个电容，是电容差不多那个一样，也是用这个产生比赛。
你找吗？
没有这些要找不要找是看你自己，看你要介绍的。我讲的这些都是我讲的这些内送的过程。他觉得我
对，要做多少去？是不是一定来过？
连找我讲的
类似，我是我是打做天哪，那正好在有。
其实我这边有很多，看到一个点，那个波函数。
不懂，应该英国是，因为我大概知道。哦，我是说，毕竟
我在想要不要至少一个 region，
因为就是我的学校
差不多这个 region 这样。啊，我这点不够用，可能要确大概一个 region。因为我怕这种来，还有一个可能这边是感觉到，但是我这边缺空很。
可能我有点写不完，你
会吐槽。
现在材料的话，另外看怎么来。那个
反正我们现在就来 test 号码嘛，就是这样，因为我们已经来没有办法把题挖出来。通常我们遇到这种情况，我们就送还三个字，看日期。
走吧，星期一的话，我跟他讲，我不要再考，可以等到我就可以再问你。
Hello, testing. Okay. Okay, let's continue. So, so we will, 怎么？Okay. Okay, so let's continue. So we'll define a set C to be closed if C is a complement of a open set. Yeah, so we'll say that C is closed if it is a complement of an open set. 什么是 complement 吗？就是不拿 S 里面的东西，拿 S 外面的东西啊？除了 S 啊？S 里面的东西是不要 ，OK 吧？OK 啊，OK。Yeah. So, for example, close this is a close set. Okay, so when we say close this, I will put open this with a bar at the top. So what does it mean? This means that we take all the point that is strictly less than delta also equal to delta. Also equals to. Yes. Okay, so why is this a closed set? So I would say that this is closed. So we need to write it as a complement of some open set. So what's the open set we can pick here? Okay, when we talk about these item, make sure you have image inside your mind. Okay, so let's say this is a close this. Okay, so this is a close this, and then we have R2 outside here. Okay, where's the open? Where's the open set? So 其实你不要盲猜，你不用盲猜。为什么你不用盲猜呢？因为我跟你讲答案，答案在哪里？I told you that close set, close this is close. Meaning what? There exists a S, open S, such that D bar is equals to R2 take away S. So what should S be? D bar equals to R2 take away S. 那 S 应该是什么？对哦，R2 扣掉 D， 所以在哪里 ？R2 扣掉 D， 在 D 的外面。对 ，OK， 很多时候其实你们现在在上的数学课你们是不用盲猜的，因为答案告诉你你要从答案 work backward 去找答案，你明白吗？不明白，明白，明白。因为读数学跟研究数学最大不一样就是这个地方。 我们研究数学的时候，我们不知道，我们要去 test。但是现在的理论已经是有了，所以它已经有 statement 好，你只要去找是什么东西就好。Okay, so now the problem is why the complement of D bar here is open. Why is it open? Why is it open? So to satisfy open property says what? If you take any point inside the set, you form there's a open disk that live inside this set here. Okay, so can you imagine that if you take any point inside this shaded area, you can form a open disk. Okay, that live entirely inside the shaded area here. But there's some problem. Right? There's some problem when you want to go close to the close disk. Correct or not? Or maybe there's some problem. Okay, when you go close to the closed disk, can you still form an open ball or not? Can you still form an open ball? Can, right? Okay. So what do? You just need to build your ball small enough to avoid the closed ball. 这种比较找小一点点，可以找得到吗？怎样找？怎样找？怎样找啊？So in particular, so meaning what？你要去找这个的距离嘛，对不对？啊，这个距离又来了，这样找，又要去这个黄黄的地方了，这样找。讲 get 到这个黄黄的距离。Sorry，拿来减什么减什么？我先 define 这个点，叫它一个名字，你是说啊？好，我叫它一个名字先，叫它 CD 啦。OK，黄色中间点有名字啊吗？Abby good，对，没有错。OK， so so to prove that this circle here will live outside this closed ball, you also use the same triangle inequality stuff. Okay, yeah, okay, can accept, okay, okay. 有问题吗？有问题吗？有问题吗？没有。那边呢？有问题吗？OK 啊，Yeah。哦，这个是蛮重要的一个 skill 啊，怎么去避免圆圈？Okay, right. So closely is close, but like what I told you last time, right? We can define close using boundary point. Okay, so let's write down another one. A boundary point C of a set C is an element AB in R2 such that 还记得我上次给讲介绍 boundary 给你们吗？当你站在边界的时候，会发生什么事情？当你站在比如说马来西亚跟新加坡边界的时候，会发生什么事情？那条线上会发生什么事情？OK，来，我们画一画。嗯，在 JB 是这样吧？哦，OK，应该要过一条河先，maybe custom 在这边。可以说这个是 custom，可以说这个是 Malaysia，新加坡。OK，如果你人站在这个边界上面，maybe 换一个 color，说你人站在这个边界上面， 会发生什么事情？你往左走一步就是马来西亚，往右走一步就是新加坡。Okay, so how do we describe this? Such that for every open disk you form around 这个 AB, disk of AB must contain points in C and points not in C. OK， 一点点你就出去了。OK， 对吗？来，我们画一个 ball around 这个边界。Let's draw a ball around this. Okay, it must contain point in C and not in C. So 这边过来就有黄的、蓝的，过去就有黄的。OK 了，这样才是个 boundary point。OK，for example 啊，我们回来这边这个 open set 啊，我们回来这个 open set。OK，你可以问你自己。OK，you can ask yourself, is this a red point a boundary point or not? Is it? Okay, so you form a open disk around here. So this open disk will contain something outside and something inside. But the theorem say, the definition says what? Need to work for all, 全部。Meaning, 如果我再把它缩小一点呢，还有这个东西存在吗？没有了。If you make a smaller disk, then all the disks will entirely contain inside the set. But if you pick a point on the dotted line here, okay, no matter what disk you pick center around this point, it will still contain point inside and outside the set. So this is a boundary point. Okay 吗？明白吗？有问题吗？ definition 发的 definition 要检查全部的 ball center， 全部的 disk center， 全部 open disk center 的这个 point， 要检查全部。OK， 要全部哦，要全部。OK， 你不可以说你住很靠近边界，你就是在边界，可是你还没有在边界。边界是可能你睡在那个船，翻过去现在就是新加坡，翻过来就是马来西亚。OK， 是睡在边界。啊，这样你是睡在边界。啊，你睡卡萨吗？翻过去 passport 要抽一下，翻过来 passport 要再抽一次，这样你才是在 boundary 上面。OK， 啊，不然你只是靠近 boundary 吧。Yeah. Okay. Okay, so another equivalent definition of closed is I will define that a set C is closed in R2 if C contains or its boundary point. Okay, so this will come out with your example in your lecture notes. Huh? Where's your example? Is your lecture note? Let's call this. Yeah. So you can see that B is a set that's not closed, but why is this closed? Because if you look at this closed set here, where's all the boundary points? Okay, so for the circle, the boundary is the points on the radius. Okay, on the radius distance. And then, sorry. And where's the boundary point for this square? It's exactly on the edges of the square. So if you put all of them together, you will get the closed. So what's the assignment question? Assignment question asks you to show two equivalent definitions of closed set. Okay, I'll let you do it. And show why the complement definition will imply you contain all the boundary. And then Y, the boundary definition will imply that you contain, you are the complement of some open set. Okay, this question, maybe you will think how to think of it conceptually. But the purpose I set this question is I don't want you to do it conceptually. I want you to do it just logically. So meaning put your definition out and then try and think, can you find an open set that you can take a complement of? Or you can use contrapositive way to do it. I just want you to use logical thinking to solve it. No need to draw this thing. And then after you solve using logical thinking, then you can try and think back what kind of picture you can draw from your argument. Okay, no? So I want you to solve that question purely from definition. Purely, play around with logic. Okay, no need to think about diagram first. OK， 不需要理解的，只要从 definition 开始做就好。然后你做完 definition 过后，你可以再想一下图上面应该要怎么理解。OK，make sense？ 因为这个是一个你们其实数学系要 train 的一个 skill， 就是说很多东西是很难想象的，但是我们是去用逻辑去推它出来。你知道我讲什么吗 ？OK， 数学有两个 view， 一个 view 叫 bird view， 一个叫 frog view。bird view 就是像鸟这样，鸟是从上面看下来，可以看到全局。frog 呢，井底之蛙，它从井里面看出来，只看到天空的一片吧。OK， 这两个 view 都很重要在数学。bird view 可能你就我看到原来是这样子，整个这样子，怎么运作？但是 frog view 呢，你只看到一部分，但是你就是要从这一部分开始去延伸，去懂多一点东西，明白吗 ？OK， 说这题那题我放在你们的 assignment 里面，是一题 frog view 的题，就是说，当你不知道怎么去想象这个 open set closed set 的时候，单纯从 definition 做。就可以把它做出来 ，OK。然后我要你从青蛙的角度去看，去慢慢延伸那个井以外的世界。等到你有一天从井爬出来，变成鸟，就会看到全部的世界。OK 了。所以那题你不用想象什么是 open set closed set 就可以做了。从 definition 吧，纯种 definition。Either you use contrapositive, contradiction or anything, or direct proof also can. OK， OK 啊。Yeah， 如果你要去理解，我不会阻止你，但是可能你会花很长时间。OK， 来，although 我不会说这个给你这个 equivalence 给你，我会说bounded definition 给你 about equivalence of bounded definition to you. Okay, so there's one more terminology we need to define is the boundedness. Is the boundedness. So a set P in R2 is bounded if for every xy in P, right? 所以如果你要 bound 一个 xy 点，你觉得要怎么 bound 呢？觉得要怎么 bound？就这样 bound 吗？觉得要怎么 bound？Maybe you can extend from boundedness of real number. Real number 怎么 bound 呢？ For example, a finite interval is bounded. Finite interval AB is bounded. Okay, so how do you bound? Maybe you can bound the two coordinate. Okay, so we bound the two coordinate using four number. Okay, using four number, maybe M, M, N, N. Okay, I bound these four numbers. Like this. Okay, I bound these four numbers here. I bound xy using this four number. So little m and little n is the lower bound. Okay, capital M, capital N is the upper bound. Okay. Actually, there's a equivalent definition here. Instead of bounding using these four numbers here, we can also bound the set using open this. Okay, open this 很好用，我们一直在用这 open this 现在。So for every xy in P, there is a open this. So open this P such that xy is in. Okay, open this. So 这两个差别在哪里啊？你觉得哪一个比较容易想象？Okay, let's start with a P. Okay, 哪一个比较容易想象啊？Humble，哪一个容易比较想象？Sorry，第一个怎么想象？什么？第一个怎么画？然后就画这样来，然后这样子，然后竖这样，N 和 capital N。说第一个其实在干嘛？你是拿一个四方形去包你的身。第二个呢？圆形，good。第二个是用圆形去包的。所以现在的问题是，如果我可以用一个圆形的去包它，我可不可以用一个 rectangle 去包我的 P？如果我可以用 rectangle 去包我的 P，我可不可以用一个圆形去包我的？也可以吗？这样。Okay, so let's start with 来，我们来玩一下这个东西。So let's prove definition one implies definition two. So 假设 if I have a square that can bound P, can I found a circle that bound P or not? 两找。Good，找一个圆比这个 rectangle 大，找得到吗？你觉得？你觉得永远找得到吗？啊，现在要变数学哦，要怎样去找啊？怎样去找就是要数学家解决啊。我觉得找得到，但是要怎样去找？diagonal 啊，diagonal。哦，you mean 用这个 diagonal 做出这个圆这样啊？是这样子讲吗？你说用这个 diagonal，然后做出这个圆，对吗？是这个意思吗？Okay, good. So I mean, one precise way to do this is what we can do translation. 我们可以for convenience 我把这个点放在00。OK，把整个东西移去00，因为我只是要帮它吧。OK，我移去00过后，我可以算它的像他们讲的这个 diagonal。 肯定是这个最长嘛，他们一定是最长哦。Okay, yeah, you need to use triangle equality to verify it. Okay, but if you use this as your radius, you can form a circle like that. 但是如果你怕的话怎样？就再长一点了，就肯定包进去了，明白吗？就拿长一点，它就肯定包进去了。OK OK OK 吗？OK right. Okay, so this is definition one implies definition two. How about definition two implies definition one? 假设我有一个圆圈的包住它了。Okay, so let's keep the diagram here. 还可以再拿一个四方形包住它。找到吗？找到 rectangle 包住它。感觉是找得到，把怎样找？diameter。OK， 所以你说的是拿这个的 diameter，这样子，and then form 一个 square 这样。OK, to be precise 是什么 ？You can again move this circle to the origin. OK， 把它这个 circle 你找到这个 circle 调去中心点 ，and then you can do the diameter stuff。有问题吗？有问题吗？So if you move your circle to the origin, then you can get your diameter here, and then you compute your square. OK， 所以你可以看到，哎，四方形可以被一个圆圈包，圆圈可以被另外一个长方形包。So they are equivalent。OK 吗？Yeah， 所以如果你要拓包一个 bounded set，不管你是用圆形、用四方形，其实用三角形也可以了，什么形都不重要，其实。OK，as long as you can bound each other。OK，有概念吗？有概念了吗？现在？OK，所以如果你去做 tutorial 题啊，你看那个 bounded shape 啊，是各种各样的，但是只要它可以被圆圈包或者被一个四方形包，它就是一个 bounded。Okay, so the full argument I write down in the lecture now, you can have a read. But pictorially is what we discussed just now. The idea is what we did just now. Okay. OK， 有问题吗？R2 可以包吗？你觉得呢？如果不可以，怎样 proof？Negation of 这个 statement 是什么？Negation not bounded 的 negation。For every 变成 there is a point inside your set such that for all m s is less than m greater than capital M, y is less than n greater than capital N， 就是说它是在这个 rectangle 以外，对吗？如果 R2 符合吗？R2 符合吗？如果你看整个 R2，你随便 form 一个 rectangle， 这不是有一个点在这个 rectangle 以外？怎样去找这个点？怎样去找这个点啊？OK，so 现在你们思想还有一点幼稚啊，不是幼稚啊，I mean 是幼稚，sorry。平时人讲的幼稚，你们是什么意思啊？像小孩子啊？我的幼稚是说稚嫩。你有这个问题，但是你不知道怎么去清楚表达。OK，说这个东西是要 train 的。OK，在这个 degree 要 train 这个东西。 你要把它清楚表达你的幼稚的问题。OK，所以刚才 Isaac 问啊，如果你在 R2 里面不是在 R2 里面怎么说它是 unbounded？ Okay. So from first definition says what? There exists a point in R2 such that for every MMNN, the following equality is not satisfied. OK，什么意思是 not satisfied 呢？意思说什么？我给你 MMNN，你就会决定一个 square 了。Not satisfied means what？它不会活在这个 square 里面，so must be outside。所以你要找一个点不活在这个 square 里面，这 square 被这四个号码 define。So 有 M， so here this point is let's say here is MN, here is little m capital N, and then bottom here is capital M small n, and then this is capital M big N。 OK， 怎么去找？有吗？R2 里面找得到一个点不在这个 rectangle 里面吗？怎样找？找一下，你只要 prove 有一个 for every 四个号码就好了，找得到吗？三元，找得到吗？找不找得到一个点不活在这个 rectangle 里面？给我一个 coordinate。看 m 加1，小 m 还是大 M？ 大 M 加1，还有嘞，大 N 也加1，可以咯。这不是 work for 全部四个号码。你给我这样大一点，我再走出去一点；给我大一点，我走出去一点；大一点，再大一点，我再走出去一点。好的 ，OK。你看我答案是很 general 哦，它是 depend on 你给我的东西。general， 你一给我一点，我就走出去一点；你给我再大一点，我再走出去一点，就够了。There exists 那个 point such that it doesn't satisfy the rectangle property。OK 吗？ OK 吗 ？OK， so R2 is not 好的。OK 啊，所以这个就是所谓用 logic 去解题啊。OK，so negation of 这个 definition。OK， 还有什么问题吗？有什么问题吗？So I mean 这两堂课，为什么我这样子教？是因为我要 expose 你 to 一些 topology 的 idea，since 我们已经用到了在我们的课里面，所以我们就 expose 一点基本的计算。And then second， 我要 train 你们的这个 logical thinking，get about 这些 definition， 怎么去真正去理解这些 definition。因为如果你进到 topology 啊，或者 analysis， 他们很少会花时间给你去看这种真正的东西。既然我们现在是在计算的班里面，这样我们就可以把这些 concept 的东西变到计算点。但你以后你进 MA2 肯定又看到这个东西，confirm 看到这个东西。因为 MA2 就是 Calculus 2的 Rigorous 版，然后 MA 是 Rigorous 1的 Rigorous 版。OK， 你肯定还会看到这个 idea， 但是在这边你就会看到清楚的一些还有坐标的东西给你看。OK，but 你学到这里就够了，我这个班我能够 show equivalence， 能够给一点例子就 OK 了。OK， 不用去到什么 Theorem。OK， 然后希望你在算那些题目、刷题的时候，有这些 idea 在支撑着你。你知道你自己在做的是在 close open set 上面，如果不 close 怎么办？不 open 怎么办？ 哪一个？if then 啊，
哦，对，
对了啊，if P then Q 哈，what's the negation of if P then Q? You should make an equivalence to using or and and statement first, and then you use De Morgan. So if P then Q is equivalent to what? Not P or Q, right? Is it? Okay, then you use De Morgan's law. So P and not Q. So if you want to prove if P then Q wrong, you need to prove that if P happen, not Q also happen. Then if P then Q wrong 呢合理吗？我问你，我本来告诉你，如果 P 发生，Q 一定要发生，但是你已经证明给我看了，P 发生的时候，Q 根本就不会发生呢。你跟我讲，本来跟我讲 P 发生，Q 一定要发生嘛，但是我已经证明给你看了，如果我有 P，我Q 也不会发生。哦，你的句子肯定不错。呀，这些东西很重要。Yeah. Okay, let's take another break and then we'll come back with calculation. Okay, for string value theorem and critical point theorem. 哎，韩波，你没有教 draft 吗？啊，对的。啊，到时候教。timing 呢？还没有教。还有呢？你还没有教。如果没有教的话，就直接评分了哦。那时候教的时候，如果你有教 draft，就你还有机会改一点。before 评分。于婚的我还没有回你，我看了我回啊。 问题。
为什么还想这样？
要写出来。嗯，
就
就是
开根号。
对，没有错。开根号是不是 imply 这个开进去？ 哎，我睇我讲翻到几时啊？
可以的。
那几时啊？我忘记了。break 到几时啊？刚才我讲，刚我有讲 break 到几时？没有。Okay, I have an announcement. So I booked next week classroom from 1 to 4, Friday at A4306. Okay. I'll break up with the announcement. Okay, so let's go to computational. So extreme value theorem says that if your f is continuous on a closed bounded set, then f has a absolute maximum value and absolute minimum value. But it doesn't tell you how to find. 没有告诉你怎么找，它跟你说你有吧。Okay. But how to find them? So we relies on this critical point theorem here. So critical point theorem says what? If f p naught is an extreme value, 它跟你告诉你要有嘛，对不对？你肯定有了，有就是说什么？你可以找得到，或者你找不到，它就有了，对吗？有没有这样的东西存在在这个世界？你觉得有，但是你找不到，还没有找到，maybe。什么？什么东西？女朋友啊，女朋友，good good good，yeah，女朋友。OK， 这东西存在，但是还没有找到。OK，yeah。But critical point theorem tells you how to find it. If f p naught is an extreme value, then p naught must be a critical point. Okay, so if you can find it, it must be a critical point. So 你可以从 critical point 里面去找它。It doesn't imply that, so very important, this is just a if then, not if and only if. Meaning, if you are critical point, doesn't imply that you are extreme value. But at least it reduce the cases you need to check. Okay, reduce the cases you need to check. So what are the critical points? Okay, so very important here. So what are the critical points here? 3 types of critical point. Okay, one is boundary point. Boundary point just now I defined already, right? So if you're a set, you need to go to your boundary. Where the boundary? There's a point where if you put any ball around it, you can find point inside the set and not inside the set. Second, stationary point. Stationary points means what? Stationary 是什么？文具啊。Yeah， 驻点，华语叫驻点，什么驻？哦，柱子的柱 ，OK。啊？没有。啊，一个买一个柱 ，OK，make sense，OK，make sense，OK，stationary，yeah， 驻点 ，yeah。So why it stays stationary? Because the gradient vector there is 0，OK， 它不会动。Yeah, gradient is 0. But in this case here, be careful. This is not the one-dimensional gradient. The gradient vector here is a vector. Okay. So what's the gradient here? Is the two partial derivative you learn from the start. Okay, partial with respect to x and partial with respect to y. What is special? Called the singular point. So what's the singular point? Is where the f is not differentiable. And your function can be continuous but not differentiable. Do you have an example in your mind? Yeah, absolute x is continuous but not differentiable. So at those points, you need to check the value again. Okay, you need to check the value. But usually our example is differentiable. For example, let's look at this one. Find the absolute maximum and minimum value of the function on the rectangle. Okay, so if I want to ask you to find, first you need to decide whether it exists or not. Does it exist or not? What does extreme value tell you? Your D must be continuous first. Okay, is it continuous here? This is a polynomial, it's continuous. Okay, actually it's differentiable. So differentiable implies continuous. I ask you to prove it. Assignment, right? That's continuity. And then continuous on the closed and bounded set. Okay? So this is a rectangle. So you can see the N or not? Okay, so this is bounded already. Is it close? Is it close or not? Okay, let's draw the picture up now. So is it close? So what's the picture here? So this vertex is 0, 0, and then 0. Here is 3, 0. And then the top here is 0, 2. The other side is 3, 2. Okay, so is it close? Okay, so there are two ways to look at close, right? Either it's a complement of an open set or it contains all the boundary. Where's the boundary point? The boundary leak on the edges here. But these edges satisfy the rectangle definition because you take inequality here and not straight. If you make it straight, then it becomes an open rectangle. Okay. So you have maximum and minimum now. So how to find it? 3 ways to find it. Okay, 3 ways to find it. How many ways? One is boundary. Second, singular point. Third, third, stationary point. Okay, so which one we should start first? Let's start with stationary point first. This is what you did in your calculus, right? Look at the first derivative equals 0. Okay, so let's find stationary point first. So stationary points means what? The gradient vector have to be equal to the 0 vector. Okay, so you need to let del f equals to the 0 vector. But what is del f here? Which is sorry, nebula f and not del f. Nebula f. So differential with respect to x, what do you get? X. With respect to x first. 不是 OK， 现在要算这个 gradient of f。gradient of f 是什么？对 ，derivative 对，两个，对不对？两个，一个 with respect to x，一个 with respect to y。OK，with respect to x 你拿到什么？嗯哼，二罢了，二罢了没？2x，觉得没有啦？你觉得没有啦？有讲完它？OK，good。还有一个呢？with respect to y 哦，this time。So with respect to y, you need to treat x as a constant. Okay, so what do you get? 什么？你卡在哪里？不明白卡在哪里？你讲一下卡在哪里？啊，不可以直接看呗？你 differentiate x square 你拿到什么？partial derivative with respect to y。没有，你知道现在要算什么吗？现在 with respect to 什么 y？OK，然后不是算 y 啊？什么叫算 x 算 y？这两句话都不明白，不可以直接算咩？Sorry 啊，我理解不了这个。 negative 什么 negative 这样啊，对，所以你在卡什么？其实哦，没有卡，卡完了没有？我想理解一下卡什么东西，我不知道啊。乘左乘右啊，讲讲看，继续讲吧，继续讲吧，讲一下，因为我要知道一下学生在卡什么东西，因为有时候他们卡的点我不明白，你讲讲看。OK，2xy，OK，啊，你是说你要把它搬去前面或者搬去后面这样啊？啊，OK，谢谢，就卡这个吧。对好什么啊？有吗？有这个以为吗？你有以为啊？你以为 y 是个 x 的 internal of x 啊？是哈？啊，所以你知道为什么 y 不是 internal of x 现在吗？为什么？这不是因为 differential 的问题，是因为我怎么 define 这个 function 的问题。因为我这里已经说了，f 是 depend on x and y，说这个 x 跟 y 是分开的，除非有多一条说 y 是一个什么 internal of x，它才是 internal of x，不然它们就是分开的东西，OK 吗？这是 by definition，OK，除非有说一句 y 是 depend on x，OK，不然的话它们肯定是分开。OK，说 OK，说这个东西很重要，就是你要看到 variable 的时候，你要 decide whether 他们是 independent variable 还是 dependent variable，OK 吗？所以你一看到你就要开始 decide 啊，决定他们是没有关系的还是他们有关系的。OK，Yeah，that's why 哦，第一个我们教的东西就是 independent 跟 dependent variable 啊。OK，所以你一定要决定它是 dependent 的还是它是 independent。OK，in this case 它是 independent。Okay, good. So if you set this equal to 0, what do you get? I think we quickly compute it. It is just, this is a simultaneous equation, right? You can use row reduction or anything you like. You should get x equals to 1, y equals to 1. 对吗？只有这个点，全部人 check 了吗？OK，I mean 这边就可以用 linear algebra 2 minus 2 minus 2 2。OK，OK，这个 reduce form 是什么？Reduce row echelon form of this matrix. Yeah, 1001. Oh, 1100. 啊？哦，sorry，我应该放去哪里啊？我应该放去这里是吧？Yeah. Yeah. So I mean, well, this one you can go and solve this augmented matrix here. Okay. And then the row reduced echelon form should be 1001. I think. Okay. Speak from answer. I think we should get this 1 here. Yeah, I should compute to this. Okay. Yeah. Can you quickly see why the row reduced echelon form is 1001? How to quickly see? No. From this matrix itself. This matrix is no. This matrix, what's the determinant of this matrix?
Right.
Determinant. Four. Four meaning is non-zero. -4, non-zero. Non-zero determinant means what? This matrix is invertible. Every invertible matrix can be row reduced to identity matrix. Every invertible matrix can be row reduced to identity matrix. Yeah. Okay, so there's only one solution exists. Okay, if it is identity matrix. Okay, so if x equals to 1, y equals to 1, meaning f11 equals to 1 also. Okay, so the value at this x11, the value at 1 is 1. F11. So inside here, where is it? So here is our domain here. So 1 live in where? Somewhere around here. So the height is 1. Okay, so it's the height 1. Okay, we found this point here. Well, the theorem says you still need to consider the boundary. Okay, so how many boundary here? There are 4 sides here. So how to describe the boundary? You know? So the boundary here is straight line. Okay, straight line you can describe as a linear graph. Okay, so there are L1, L2, L4 here. So you can see that L1 is a horizontal line that contains 0, 0, and 3, 0. How to make this line? How to draw a horizontal line? Of what? Y equals 0. Okay, y equals 0. But y equals 0 is the whole line, right? So we want to restrict the s from where to where? From 0 to 3 only. Okay, I don't want the whole line. I just want x from 0 to 3. L2 is a vertical line. How to form a vertical line? How to form vertical line? Right? X equals what? 3 in this case, okay? Because the x coordinate is fixed, but I don't want the whole line, right? I just want y from 0 to 2. Okay? So L3 is similar, no? Where's the horizontal line here? Y equals to 2. Because you can see that the y coordinate doesn't change. Okay, y equals to 2. But I restrict my x from 0 to 3. Okay. L4, so yeah, x equals 0. But I want to restrict my y from where to where? 0 to 2. Good. Okay. So let's compute for all these cases. Let me compute one and then I let you compute the rest. So on this L1 here, what happened to my function? Let's write down my function here. fxy equals to x squared. What happened to my function here? My y is always 0. Okay, so I reduce my function to x squared only. Okay, so on the surface, what are you thinking here? So look at this surface here. If you look at this surface and then you just look at the line y equals to 0, where is it? Let me see. So I think this side is x. And then this side is y. So let me draw this. Okay, so where is the y equals 0? Y equals to 0 line. Is it confusing or not, this x and y? Y equals 0. Yeah, okay, so L1 is here. So you can see that if I restrict to L1, you really just get a x squared function here. 看得到吗？看得到吗？ Can you see what am I drawing here? If you just look at this one, okay, 颜色不是很好，我换一个颜色。颜色不是很好。颜色，因为太亮了。Okay, right，这样子嘞。Okay. You see, if I look at the L1 here, and then you can see that your surface is going up like a x squared. Okay. So, well, if you look at the function of x squared, where is the largest? So let me draw it. Let me draw it here. So if you have an x squared here, and then it's going from where to where? So this shouldn't be y, this is a z. And then your x is going from 0 to 3. Okay. So where's the highest point here? Where's the maximum? We want to look for maximum, right, and minimum. So where's the maximum and minimum in this case? Huh? So the largest happen at 3, 0. And then the smallest happen at 我抄错了，等一下，等我一下。At 0, 0，这个是个 minimum smallest. And then the other one is at 3, 0, which is 9. Okay? Or 看得出吗？最高跟最低的点，我这个方程。In general，你怎样找啊？这个问题其实 is a calculus one question. So what can you do? You reduce to the calculus one case. You also do first derivative. Okay, and then you find where's the maximum minimum. And then you check on the boundary. Where's the boundary in this case? 0 and 3. Okay. Okay, so try 算一下，给你们3分钟算完其他 case。Smallest 跟 largest 差你。Okay, so let's see. If you just look at L2, what happened to our function? Our function will reduce to 9 minus 6y plus 2y, which is what? 9 minus 4y. Okay, so it's a linear graph there. And so when's the largest? When's the smallest? So let's draw the graph out also. So you have y on the x-axis, and then you have z on the vertical axis. Okay, and then where's 9 minus 4y? So you have this direction. Okay, but you just look for y from 0 to 2, for example. So my guess is smallest, largest at y equals 0, smallest at y equals to 2. Okay, is it true? Do you get this answer here? So F30 is the largest, and then smallest it is at F32. You get this? Get this? Okay. Okay. Good. How about y equals to 2? The function you get should be a quadratic function here, centered at 2, the smallest and largest here. Smallest is at F2, 2, and then largest is at F0. Okay, correct? Agree? Okay. L4, smallest at where? Maybe I don't want to write the function down. Where's the smallest one? Huh? 0, 0. You get 0. Largest, you get 0, 2, 4. Okay, so how many F you computed? Do we have singular point or not? We don't have, right? Because this is a differentiable function. So how many things we have computed? 1, okay, use different color. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so you need to compare these 9 value here. Which one is the largest one? So we only got 0, 1, 4, 9, right? Okay, 9 is the largest one. And then what's the smallest one? Smallest one is the 0 point. Okay. How many points have absolute maximum? 3, 0 and just 3, 0. Okay, so we have absolute maximum at F30, which is equal to 9. Okay. And absolute minimum is 0. How many points we have minimum value? Absolute minimum. We have 2 of them. Okay, one of them is at the origin, the other is at the 2, 2. One is at the origin, one is at 2, 2. Okay. Maybe let's see. Let's see. Let's plot it. Let's plot the graph. See is it correct or not. This graph. Okay, so this graph looks like this. X squared minus 2xy plus 2y. So let's find the x, y, z axis. So like this. Okay, so there are 2 minimum points, which is 0, 0 and 2, 2. Okay, so 0, 0 and 2. Is any contradiction or not? Absolute minimum. You contradiction, ma? You can see that actually there are lower value, right? But is there a contradiction to what we found just now? 讲最小的点是00跟22，但是好像还有更低的点了，有 contradiction 吗？有吗？有 contradiction 吗？没有，为什么？因为我们只是看一个区域里面最小。Okay, so we only look at a rectangle. Where's the rectangle? From 0 to 3 times 0 to 2 in y in x from 0 to 3 in y from 0 to 2. So only on the first quadrant here. Okay, so in first quadrant here, the rectangle, the lowest point is 0, 0 and 2, 2 here. Okay, where's the highest? It's 3, 0. Where is 3, 0? 3, 0 is here, this side, the highest point. 是最高吗？看起来会很轻，不是很容易看。Yeah, I mean on this side, on this side is the highest point. Okay, maybe you need to compare both sides. 可是 quite symmetric，但是看不出，看不是很出。Okay, but you can see that it goes higher on the direction coming to us. Okay, but 不是很看得出左边跟右边谁比较高。你看得出吗？你们？我是看不出啊，很 symmetry 一下感觉，但是就我们只找一个最高点吧。Okay, yeah. Okay. Okay, continue. Okay, next. So next, we'll decide what is a local max and local mean. So this is similar to what you have in your calculus 1, where you check the second derivative test. Okay, but the second derivative test here is special because note that our gradient here is a vector. Okay, so how do we get number from these vectors now? Okay, so start with the theorem first. If f has a local maximum and minimum at x naught, y naught, and the first order partial derivative of f exists there, then the gradient vector is equal to the zero vector. Okay, so meaning if you're gonna find local max or local mean, the gradient vector is also equal to 0. Okay? So meaning you need to find these local max or local mean using what? What are the points that satisfy gradient vector equal to 0? 我点的 gradient 是不会动。One of the critical point. 有3种 critical point, stationary point. Okay, so meaning if you are local max or local mean, you must be a stationary point. Okay, so you start from collect all the stationary points first. Okay, after you collect all the stationary points, you need to compute this d. This d 看起来有点复杂。What is this d here? You need to compute the double derivative of your fxx times fyy minus fxy squared. 这东西其实很像一个东西 ，AD 减 BC. So actually, this is a determinant of a matrix. So what matrix is it? 以前学过啊？哦，两位数学过，是用 second derivative 做出来的。哦，是吗？哦，right，对啊，那个有关系，那个有关系。Yeah，那个有关系。So this is a determinant of fxx, fyy, and then fxy on okay, of this matrix. 所以如果你不要记这个 d 也不用紧，你记这个 matrix 就好了。OK， 这个 d 是 determinant of 这个 matrix. Right. So there are 3 conditions here. If this determinant is greater than 0, 2 cases will happen. Either fxx greater than 0 or fxx less than 0. If it is greater than 0, then it's a local minimum. 很像你们 calculus 1嘛 ，second derivative 大于0的话，它就是一个 minimum. If the second derivative sx again less than 0, then f is a local maximum. But 你要比你们的 calculus 1多算这个东西，你要算这个 d 键，你要 make sure d 大于0才开始算 fxx。OK， 其实这个东西很神奇哦。
is a very interesting because you can out of 4 of them, you just care about fxx. 就很奇怪，只要 check 一个方向的 second derivative 就知道它是高还是低的。And so this theorem is kind of strong because this determinant 已经绑定他们4个的关系绑起来。So somehow 一个东西可以决定其他的。Together with 这个 D 啊，这个 D。可以想象我在讲什么？可以讲你比较好的，这样讲。我可以就是来引导你去想一下这个东西。你想一下，如果这个 D 要大于0啊，是什么情况？这个号码减掉这个号码要大于0，但是这个 square 肯定是一个 positive number。So meaning what？ 这两个的 product 一定要大于 fxy 的。但是如果 fxx 是大于0的话 ，fxy 就不应该要小于0，不然的话，你的 D 就不会是大于0。如果你 fxx 要小于0，你 fyy 就不应该大于0，不然你就拿一个 negative 减掉一个 positive， 你就不可能大于0。不要用那个但是你可以回去找他们的关系。但是我应该讲到蛮清楚了。这边有谁哈？这边有谁？
忘记了，没有很看他们写了。OK 呀、OK 好，好像没有写，sorry。OK，
还有什么情况 ？If D is less than 0，不用检查了，它是一个 saddle point。那时候 saddle point look like this。为什么会把 saddle point 从其他的 case 分辨出来啊？知道吗？不太 precise， 就是说它附近的点有些上去，有些下来。但是如果 local mean 的话呢，它周围的点都是上去的。local max 呢，周围的点都是下来的。所以如果你要做一个 stationary point 你最好是做一个 local mean， 你不可以做一个 local max， 知道为什么吗？因为如果你是一个 local max， 虽然你是 stationary， 但是我 perturb 你一点你就跌下来，我弹你一下你就跌下来。但是如果你是个 local mean， 我弹你一点，你往上去，你还是会回来的，明白吗？所以做人不要太骄傲，谦卑。OK 吗？
还有一个 case 没有讨论到等于0，等于0 the test is inconclusive， 不知道。OK， 不知道是什么。Alright, so let's do one example here. Let's quickly do this. I think 做好这个我们应该就可以 break 了。需要带你们做吗？还是你们先做先？那你们去转先去转吧。我给你3分钟。想 start 是不是不用看 boundary point？ 对，有没有 boundary 这边？没有啊。I mean, if you want to find local max or local mean, do you need boundary stuff? You don't need. You don't need. Only for absolute. Yeah, absolute maximum minimum you need boundary.
Because here we don't care whether the local max or local min is absolute. Okay. So to be a local extrema, what sort of point satisfy this? It has to be a stationary point. So if it's a stationary point, what is stationary point? The gradient vector is 0. So you start from there. Maybe 谁算好这个 gradient 可以念出来。OK， 如果我 set 这个去0，有什么可能性啊？全部人有算到几个可能性啊？啊，3个。OK， 看一下是不是一样啊？诶，对吗？全部人有算到这3粒点吗？说这3粒点配什么 y 呢？为什么 y？ 啊，一样的。哦，OK， 呀，一样的，确实。Right. So what's the next thing you compute? You compute the determinant, the d. Okay, determinant of fxx, y, and fxy. So you should compute what is fxx first. And what is fxy? And also fyy. OK， 有3个点。OK， 谁算了 fxx 是什么 function？ Curve x square。Sorry， 对 ，OK。fxy 呢 ？OK。fyy y square. So d is what? D is fxx times fxy minus, sorry, times fyy minus fxy square. Okay, so when xy equals 0, 0, what do you get? 来，谁上了 -16, which is less than 0. Less than 0 is what case? Saddle point. No need to compute fxx already.
At 1, 1, 1 to 8. -1 also 1 to 8, right? Because you can see that these two function is symmetric. Okay. 1 to 8 greater than 0, 1 to 8 greater than 0. So we need to decide what is fxx now. So what is fxx for 1, 1? 12. Okay, which is greater than 0 again. So greater than 0 meaning it is a local minimum. Okay. And the other case is also 12 because it's symmetric across s equals 0. So it is also a local minimum. So let's look at the graph here. So 这个是有一点像两个，就像一个裤子这样的图。Okay, so what can you see here? At 1, 1 and -1 is the local minimum. And then at the origin is a saddle. Yeah. So this is a level curve. Can you realize this is a level curve? If I tell you the height, you can build this head. Okay. 有问题吗？问题吗？ Okay, so next part 是那个 about Lagrange multiplier，我们不会 cover，不想算那个东西，你可以学，但是我们不会考。OK， 因为如果纯粹算的话就没有必要学，我觉得，因为纯粹算你也学得会，但是它的概念是蛮深的，其实 Lagrange multiplier 我们不会考。OK， 你要学是可以，我们不会考。哎，有这些算法在里面。So after 这个我们就会进double integral，我们会进 double integral。And then double integral 进了过后，我们 quickly recap vector function，那我们就会进 Green's theorem，然后我们的课就要结束了。OK， 有问题吗？所以 next week 我们有一个 extra 的 1 hour， 看一下我们能不能提前交完。我不知道我们是迟了还是我们有迟吗？好像跟我上一次 summer lecture note 的话，应该是还好。所以我们再看呢，因为每次我们到 vector calculus 都会蛮快的，所以看一下这次可不能放慢一点。我们 try 了 ，OK。如果真的来不及，可能要 extra class， 应该不会了，我觉得。OK。Alright, so see you next week.